Guys, Wages World here. It's December 11th, 2019. I'm the artist formerly known as Blue Kool-Aid, and I'm going to try to do a video for you. What I'm going to do, guys, I'm going to show you some space weather conditions because I haven't been doing the model updates, but we also had some CMEs, guys, that popped off, and I really want to show them to you because it lit up some objects. And we're going to talk about that volcano in New Zealand also and what space weather had to do with it. Okay? But as you can see, solar winds 397. Geomagnetic activity, guys, that's beautiful. Okay, it's in the middle. That's what we want. We don't want it up 5, 6, 7. 5 and 6 is usually okay also, but we do see some effects from that. But we start seeing it up here, then we got to look at electrical disruptions and stuff like that. But we also don't want it in the basement because extended periods of time with no activity increases the risk of cosmic rays, which turn into muons, and those muons will affect the human body, guys, and make us sick. Extended periods of time of exposure to that and more of them. But anyway, here again, this is the ACE graph. This shows you in yellow is the solar wind speed, the orange is the density, and the green is temperature. Now the blue is the phi angle. We've talked about that before. Sometimes that switches polarity, and it does give us a little jolt most of the time when it does that. So that's why we look at that. But right now, conditions seem to be pretty decent. Okay. Now this is the Enlow model. Right now we're sitting about the 12th UTC, which stands for Universal Time. And whenever I talk about time here, usually I'm saying universal time. So anybody that hasn't been watching for it any amount of time, that's what I'm talking about when I say that. Now, we're looking for an increase between the 13th and 14th. Okay, as you can see here. Something I want to point out, that's only an increase of 200 for the whole graph. Sometimes we'll get over here and it'll say 200 all the way up to 800. So it might not look as impressive, but it could actually be a bigger increase. So that's what we have to pay attention there. But anyway, as you can see, and what's going to cause that increase is a coronal hole that kind of rotated Earth facing and rotated on through. So they forecast this out 5 days in advance. And this changes from hour to hour a lot of times. It's a model. Okay, just like your local on the 8s or your local weather station. They change it all the time. Same thing goes with this. Okay, here's our auroras. Those are northern lights, guys. That don't know. Those always increase when we get solar weather. So with us being kind of in a normal range, you can expect normal conditions with that. What happens is when we get solar storms, this green that you're seeing actually will dip down into what they call mid-latitudes. And that means closer to the equator. So that's why we look at that graph. Again, this is showing the same stuff was up there in those other graphs. But yeah, so we're going to go ahead and talk about the CMEs, guys. Just give me a second. Okay, guys, I'm going to show you these CMEs and what we've seen inside those CMEs. Okay, now what we got here, guys, this is seeds. I take everybody here all the time. See all these gray boxes? That means it's missing data. It's not there, right? Well, that's wrong. Okay, I learned something today on this part of it. And I think I was shown this once before, but I actually forgot. Because usually all the data is there, guys. It puts it there. Well, let me show you how to get to it. Click on one of these other boxes. You see that? That takes us back to 11:30 because that's the date I just clicked on. All right. And guess what? See that? It says monthly table. Click on that, and it's going to take you to the date you just clicked to, that corresponding month. So we're looking at November, right? But we're in December, right? So we want to see that one. Well, there it is. Next month. Watch. It's all there. All that missing, what I would have called missing data, is there. It's not missing. It's just not on that front page. I do think that's intentional, okay? Just so you guys know. I think that sometimes they don't want to completely say, hey, you couldn't have went and looked at that data. They just made it harder for us to go see. Because I don't know the reason why it wouldn't, if it's here, This is the same site. Why wouldn't they just put it in the front there also? Makes no sense to me. So anyway, we're going to go ahead and move on. So I'm going to take you to the 9th. Well, actually, I'll just take you to the 10th because this is pretty dramatic right here. So what you're seeing is the CME. Actually, it was 2. Okay, you see this one over here and this one. But what you're looking at there is obviously it's not huge, but it's definitely not small. Okay, so we're looking at this right here, right? It's there in the red also. I'm not adjusting this at all. I'm just showing you guys the raw right off of this site. Okay, now as we're looking at this, like I just said before, the Earth's here, okay, and we're looking this way. So if we're looking at this, from this vantage point, it looks like this thing is blowing straight off to the side, right? Because we're here. Well, let me show you why that's not the case. So I'm going to pause for a second. Okay, so I took you back here to the home page of seeds. Well, if you go down here and you go to stereo A, you see stereo A down here? Click on that one, which is the same day. Now again, the Earth is here. I'm sorry, that is wrong. The Earth is here because we're at a different satellite. This satellite's over here looking at the sun, right? The Earth's over here. So according to what I showed you just a minute ago, it looked as though, because again, the Earth's here, it looked from that vantage point, from the Earth's vantage point, it would have been blowing off that way. Well, it's not. It's actually blowing off this way. Not straight, but actually back towards the backside of the sun. Away from us. And the reason being is, again, this is on a different satellite. Okay? This is on stereo A looking from this way. That's why we always look at both, because it gives us a better sense of direction. So to give you a little recap there, the Earth is here. The one we looked at first is from a satellite right there. This satellite sits over here. Stereo A. So that is the difference, in case you guys didn't know. And if you look at, you zoom in here, you can clearly see it's getting fired off to the side, yes, but also towards the back. Okay, so it's more at an angle. That is not going to affect us at all, just so you guys know. Okay, guys, so this is the main part of that. Okay, first thing I want to point out is, yes, there was another CME here at this, basically almost at the exact same time, but that's the biggest one, right? Now, I'm going to take you back to the 9th because that's actually when it started. All right. Scott made some great captures over on Cactus and shown this. He made a video of it. I'm not sure if he posted that video yet. He sent it over to me, and it definitely, oh my gosh, wow. That's all I can say. I may show it here in just a second, but I'm going to take you back to the 9th. All right. Because this is actually when it started. So as you can see, stuff is starting to happen. All right, now I know this is loading kind of slow, but you see the brightness over there on the right and on the left? So I'm going to back it off just why it does this. Now that's typical. You guys see how that blacked out for a second? A lot of times we see that because it does shoot out a bunch of energy and light. So sometimes the camera doesn't get a chance to catch that right away. But I'm gonna show you guys something really interesting that I think is actually going on. Okay, so I'm going to push start here, and we'll try to stop it right about there. Okay, I'm going to back it up. So what I want to point out first off, okay, I've talked about this before. You see this smaller part over here, smaller CME that came off the other side of the sun. It's almost exactly 180 degrees away from this one. Now, I've talked about that, like I said, before, but kind of briefly. Now, that's an observation I've made. Okay, I'm not sure if there's any science behind this or not, but whenever there's a CME that I've noticed, almost every time, almost exactly 180 degrees, there's a smaller one happens at the same time, or really close to the same time. Why is that important to what we're talking about? Well, the reason why is because, picture this. The Earth is here, okay? And then say the sun had a CME that blew directly off the backside. What would that mean for us if what I said happens almost every time? That would mean that a smaller one, or roughly the same size, would be 180 degrees fired off the other way, right? So what would happen? It would fire right at us. So, yes, we need to pay attention to when there's backside CMEs, because this is exactly what can happen. And that's why I do kind of, put that out there and stress that, because I don't hear a whole lot of other people talking about this, if anybody. But it's just, like I said, it's an observation that I've made. So we'll keep moving with that. But as far as I can tell, almost every time that happens. So that's why I pointed out. Now, to this. Okay, yes, that one happened there. But as you can see here, sorry, I'm just trying to give you guys the best picture I can here. I'm going to back this up some, because I'm going to take this frame by frame so you guys can see it. Okay. Actually, I think I took some screenshots of this. Hold on just a second. Okay, yes, I did take some screenshots. So, this is at 1948 on the 9th. What am I talking about right there? Okay. I could put some contrast and stuff on that, but what you're going to see is my opinion, that's an object. Okay, and the reason being, obviously it's spherical, but watch it stay pretty much in the same spot. Okay, I'm going to just go through these. Sorry about that, guys. Anyway, you see that right there. That's the next capture. That's the next one. Hasn't moved. Still there. There's the next one. Still there. Still there. Okay, and that's the last screenshot I took. So what I'll do is, guys, again, keep in mind that did not move. That stayed the same distance. And we would expect that because there's not a whole lot of time there. Okay, it goes from, let's see what the time frame is, 1948 UTC to 2036. Not even an hour. And it stayed the same. Stayed in the same spot. So that just gives credence that, yes, that's an object, guys. Now, what do I think's going on here? Again, I think that our object's coming up from the backside of the sun, and it's causing these reactions. Okay? Now, also, we've seen multiple objects. Okay, because this is cactus. That's what Scott caught the other day. All right? Now, you can see right here that I do think that there's more than one object here right now. Okay? If we zoom in, and this is a different tool. Okay? Same satellite, but different tool. Now, that's on the 10th. The ones I just showed you was on the 9th. That moved a little bit out, you can tell. So it did move some. So, let me, you know what? Maybe I'll just, let me pause for a second. Okay, guys, here's a video that Scott made up. Now, this is the 10th. Look at this thing. And this is on cactus. This is not seeds. But it's showing you the same thing. So, okay, guys, this is the 10th. All right. Now, it's after I showed you guys. Okay. Now, what I think's going on some of these captures, guys, is something that's called magnetic draping. Okay. Now, our main object, we 100% think that it has an electromagnetic field that interacts with the sun. Okay. But magnetic draping is something that happens on an unmagnetized object, such as either a smaller planet or a moon of some sort, just something that isn't magnetized. Okay, and that happens with magnetic draping, and it has to do with plasma. The plasma that's getting shot off here is actually draping around the object, and it goes on off through. Okay, there's a similar effect when solar wind hits Venus. What I can understand, the research that I've done. I'm not going to get too much into that right now, because this trying to explain magnetic draping is a very long conversation, because it takes a whole lot of explanation to really understand it. But so I'm not going to go into it right here. I may do that in the future. But I do think that some of this may be magnetic draping. But obviously, it couldn't be from our main object because it has electromagnetic field. So I do think that this smaller object I just showed you guys on the 9th does have this. Now, when we see the magnetic draping, as that plasma flows across that object, it will still keep a similar shape, but start to spread out as it gets past that object. So it would look very spherical for a while and then kind of spread out. And that's exactly what we're seeing here. Okay? Because the object I showed you was about right here, I think, as I zoomed in here. Let's let this thing move across here, go back to the time frame. Now you see that? Okay, so it looks as though it spread out right there. So it went, maybe that's what's going on here. I could be completely wrong on this, but that's just something I've been kicking around in my head. Just trying to figure out if that's actually what we're seeing. But I do think that there's more than one object in that this CME is actually lighting up right now. I think our main object's in there, and I think that, and we've caught more than one object together before. And I do think that sometimes that's what we're seeing. But regardless, the CME definitely lit something up. And again, guys, our object that we talk about in the 28-day orbit this would be in that right spot, because this is not blowing straight off of the sun to the right from our perspective. Okay? We would expect our object to be coming up around the backside of the sun right now. And with this CME blowing off that same direction, most definitely points to, what we talk about with the 28-day orbit thing that we always speak about here. Okay? I do think that our object is probably the biggest cause of what's going on with this. So, but yeah, so I'll back up to the next day and I'll show you that, what we caught there. And I'll pause it again, but as we get to it, okay, I'm gonna back it up some. But yeah, guys, I do think that that's probably what's up. Now, I was glad I was able to. Scott actually, I asked Scott. I said, is there any other way to get to this data? And he showed me this right away. So this is what, experience brings you. He's had a lot of years of looking at this stuff. So yeah. Let me back it up some more so we can see a better capture of it. So yeah. Now, as I was saying, guys, about that magnetic draping thing that I was talking about, you actually kind of see that here. Okay? Because right here's our object. Now, I'm going to slow this down and just let it play. Okay? So, let me slow it down. And I'll back it up a little bit more too, just so we can. Alright, so I'm going to start it. Okay, now watch. Because our object, like I said, is about right there. Oops, it's going backwards. Sorry. Let's reverse that. Okay, here we go. Watch. See how I hit that object and started draping around it? See that? Ain't that kind of crazy? But anyway, yeah. So hold on a second. Okay, guys. I think I am going to end the video there tonight, guys. I was going to go ahead and show you guys what I thought the space weather would have had to do with anything with that volcano that happened over in New Zealand. I'll talk about that in the next video because I want to give it about the same amount of time I gave this. I don't want this video to go extremely long. So yeah, hope you guys can see that and hope you guys can understand what I was trying to get there. You know what? I'm going to pause it just for a second. Okay, guys, I just talked about magnetic draping there for a second. I'm just going to show you guys this. Take a screenshot of this if you guys want to try to research that at all. But it definitely has something to do with exactly what we talk about. Okay, has something to do with the way that plasma drapes over an unmagnetized object. Okay, that's a very basic way to say it. But this actually goes into some detail. So if you guys really want to know what this is, just take a screenshot of that or go over to this. This is actually Wikipedia's definition on bow shock. Okay, but it has subtitles here that you guys can click on. If you just click on the magnetic draping effect right there, it'll be there. If you just Google it, it's there. There's a lot of stuff that can be talked about when we're talking about magnetic draping. Obviously, you see Mars is in here. You see Venus is in here. I do think that it actually talks about Venus. Let's see here. Yeah, I'll just read this first paragraph. A similar effect, known as magnetic draping effect, occurs when plasma flow impacts an unmagnetized object, such as what happens when, get this, the solar wind reaches the ionosphere of Venus. Okay, the flow gets deflected around the object, draping the magnetic field along the wake flow. Okay, and again, I'm not going to go into detail with this right now, but like I just said, it's basically the way that plasma is flowing over top an unmagnetized object and what it should do when that happens. And that's what, that's kind of what I thought we might be seeing there on the objects and stuff I just showed you guys. So, anyway, guys, remember, Wages world where truth is sought and fear doesn't exist. God bless.